is Jesse Morrison. I'm an assistant research professor here in the Department of Plant and Soil Sciences at Mississippi State University. I work in plant breeding, variety improvement, and general agronomy. So come with me, I'll show you around. So I'm originally from North Carolina. Grew up in the mountains. I grew up outside a lot, so I didn't really realize it at the time, but I imagine that's where my passion for what I do now really started. I got a bachelor's degree at Berea College. It's a tiny little school in central Kentucky. I moved from there about 30 miles up the road to the University of Kentucky. I got a master's degree there in crop science. When I started here, I came to Mississippi State for graduate school for a PhD, so I started that in 2010 and finished it in 2016 and have been here ever since. Passion for research really didn't start until I was finished with my master's degree. I got done with that degree and I was happy to be done with school, and I wanted to go get a job and work and do something other than go to class and you know, do lab work. But it took a couple years of being done with that to realize that I really did enjoy that work. I really enjoyed the challenge. I enjoyed being able to be inquisitive and be in a place that fostered that. Yeah, passion for research definitely didn't start until later in life, but a passion for, you know, plants and the outdoors and the natural world was with me from the time I was a little kid. I just didn't realize it. The Department of Plant and Soil Sciences is probably one of the most diverse departments we have on campus. You know, it encompasses just, you know, straight up agronomy, row crop research, you know, food crops, horticulture is in this department, turf is in this department. So it's a very broad, wide-ranging thing. You have joint appointment extension specialists who do research and extension work, research and teaching, 100% teaching faculty that cover a pretty wide range of disciplines. My favorite thing about the department, I think, is something we just sort of touched on, is really the diversity in it. You have an opportunity to collaborate with numerous different faculty, different backgrounds, different research interests, and you find pretty quickly how much our interests overlap, even though, you know, the people we just met in the hall may work in turf technically, and I might be in plant breeding and agronomy, but we have similar interests, and we wind up collaborating pretty often on research projects, grant-funded projects, that sort of thing. So that's my most favorite part, just the ability to interact and work with people from diverse backgrounds and with very diverse interests. My interests mainly focus in germplasm improvement and plant breeding. So I came here, like I said, to work on a PhD, and I started that work in just native plant establishment, improving establishment and germination of some of the seeds we looked at earlier, some of those native grasses. And that evolved into breeding those species for those improved characteristics, as opposed to trying to force it with some sort of, you know, exogenous treatment like hormones and chemicals and that sort of thing. So now my main interests are improving native species for specific use in the Southeast. We have lots of native plant, native grass breeders across the country, but we don't have very many in the Southeast. And the Southeast is a very unique ecosystem, very unique climate, and lots of land that would benefit from increased native plant populations, but we just don't have readily available adapted germplasm that is available for producers in the Southeast. So, like I mentioned before, my work here really started in native grass improvement. So, you know, 6 or 7 or 8 different species of native grasses, mostly large native grasses, traditional prairie grasses that we work with. That has evolved now into native legumes and forbs. So some of the plants we're looking at upstairs in the growth chambers are smaller stature, serve a different role from a food source perspective as opposed to habitat that the taller stature grasses serve for wildlife. So we've been working with grasses for 15 years now, and we've just started getting into legumes in the last 5 or 6. So that's really the newest thing we have as far as germplasm improvement. I would say that all of our inventions have probably been equally as notable. You know, they're the same native plant species that we were talking about. So far, I think we've released 4, maybe have 3 more in the works. But this suite of large stature native grasses and moving on to the native legumes and forbs that we were talking about will essentially be able to supply, 70 to 80% of the interest in native plants through the Southeast. There are hundreds of native species that people are interested in, but as far as land reclamation, ecological restoration, CRP plantings, that sort of thing, you're focusing on 10 species or fewer, and we've captured all of those species. So outside of the university setting, the biggest influence we would have is directly with landowners and either livestock producers or forage growers who are interested in either incorporating native species into their existing programs, or who have plots of land that they're interested in planting in something like a conservation reserve, or planting specifically for wildlife habitat, or who are just interested in improving habitat around their property in general. It also extends to state parkland, national parkland. There are always areas that are under some sort of species improvement program or invasive species removal program. So offering southern adapted native species, native germplasm that those landowners or those land managers could use that would be well adapted to the areas that they're going to be growing them in. That's our biggest impact area outside of this place. Oh man, time, like the seed that we were looking at earlier, some of these seeds they've evolved over thousands of years, and we're trying to change them in 4 or 5 or 6 years. We're trying to essentially reverse or change course of what's taken place over ages, and it's difficult. It's you screen a lot of seed and a lot of plants, hundreds of thousands of seed a year to get 100 that do what you need them to do, that germinate readily, that establish quickly, that tolerate the southern ecosystems and climates. And that's just 1 year's plants. Then you have to do it again the next year and the next year. So it's a long process that you don't get a lot of instant gratification from, which is difficult for a lot of us. It's nice to turn around at the end of the day and see the results of your work, and you don't get that. You can turn around at the end of 5 years and see, here's what I did. But yeah, time is the hardest part. From my point of view is a remarkable amount of support from this department, the college, the research station system. I have never felt like I didn't have freedom to do what interested me. At the same time, the students that we get, both from the state of Mississippi and from other states, are remarkably curious and interested, and it's never been hard to find undergraduate students willing to do hourly work in something that they've never done or seen or experienced. Crossed plants, they've never harvested pollen, they've never done any of that, but they're always excited to do it, and they make doing this work that takes quite a bit of time, they make it a lot easier. We're lucky. We're lucky as a university to have a lot of support from our administration, but also a lot of student support. I mean, it's the students make this place go every day, and that doesn't end at like the classroom door. They make our job easier, but also just more enjoyable.